YG전자, 즉 YG 전략다루 본부는 YG의 미래를 책임지고 있는 팀이죠. 나이도
using conda activate and delive. Let's type in the same. Delive.
What's going on, everybody? Welcome to another OpenCV with Python tutorial. In this tutorial, we're going to be talking about object detection like face detection or eye detection. Use onto this video. I'll put a link to this in the description. If I forget, I really probably will forget to put a link to this one in the description. Let me know. There will be a link to the tutorial in the description as well, and then this link would be in that tutorial. Now, this is just a quick kind of dump of various cascades, and the way that these work, these are hard cascades, and the way that they work is they are massive XML files with a lot of features, probably, or something, a right eye that you can just find, but a lot of times you might have an object you want to track that you can't find, and that's what we'll talk about next time. Till then, we'll grab the eye and let's get the frontal face default. So these two files, go ahead and take these files, download them. Just take note, these are licensed to Intel, so make sure you understand the license before you go using these, commercially and stuff. So take these two cascades, download them, put them in your, and to download them, you just go to raw, right click, save as, okay? Save them to where you're working, both of these, and then you're ready to go. And here I'm going to show you how they work. So to start, you're going to want to have numpy as np and cv2 imported. And now we're going to define the two cascades. We're going to have a face cascade, and then we load in that cascade, which was har cascade underscore frontal underscore, or actually it's not an underscore, frontal face underscore default dot XML, HTML. Anyway, face cascade was that, and then now we're going to say the eye underscore cascade, and that, let me make sure that, and camera is being, we're going to convert it to gray immediately. So we're going to say gray equals cv2.convertColor, image cv2.color underscore bgr to gray. Now we're going to say the faces here are going to be equal to face underscore cascade dot detect multi-scale, and then we're going to detect on gray. And then we're going to say, we're going to use 1.3 and 5. We can talk about these probably later, just you can use these. Basically, it's going to be, depending on the size of the image you use and the likelihood that you why the that really want to even kind of stuff. And then gray for our eyes. So IX ROI anyway equals so like your eyes will be detected and hopefully your face is detected. Now if I take off my glasses, it probably works a whole lot better. So The glasses are just going to cause problems. Your eyes now error. I did this the last time. Why do I keep doing that? Anyway, okay. So we've got this camera running. Now I have to look at it, but you're probably my mouth get. Let me move this over. Actually, dang it. I can't really move it, and then you see it because it's hanging over. Anyway, so like your eyes will be detected, and hopefully your face is detected. Now, if I take off my glasses, it probably works a whole lot better. So the glasses are just going to cause problems, just because they're like one more thing on your face. And then my mouth is apparently also an eye with this cascade. So anyway, there's that. But I think that's pretty cool that you can detect a face, and as at least for me, it is extremely efficient for object detection. It does not take much computing to do it, right? It's going to use, like, the HAR cascade itself is very small. Let's see, the cascade here. The face is pretty big because it's hard to find faces, but it's not even that big, right? It's 909 kilobytes. Okay, so yeah, it doesn't take much memory to really load those into RAM and be like looking for those. So that's pretty cool. Like, it's just they're just so small, yet they're so powerful for detecting things. So naturally, you would be inclined to want to make your own cascades, because chances are maybe you want to track something else. Maybe you want to track a phone or glasses or a microphone or just anything. Like, how would you even get started tracking something? Well, it turns out you can make your own HAR cascades, but HAR cascade creation can be hard. Anyway, if you laughed, I appreciate it. So that's what we're going to be talking about in the next tutorial, is how we can go about creating our very own HAR cascades, which is actually quite the process, but you can get through it. It can be done. And once you do that, you can track any object. Like, that is so cool. So that's what we're going to be talking about in the next tutorial. If you have questions, comment, concern, whatever. Oh, you know what? Actually, before I kick you guys off, let me just try the defaults on this face detection. So it's not that bad. It finds a face, and it's not finding faces all over my house. But later on, when we do our own well, I just found some weird faces there. When we do our own HAR cascade classifier, you'll see that it's very important that you throw something in there. And it's probably because our cascade is not going to be the greatest, because to make really nice HAR cascades, you need a lot of RAM, a lot of CPU, and a lot of time. Series, you'll probably use a 0 to bring in. Won't take too long. But anyway, on to this video. I'll put a link to this in the description. If I forget, I really probably will forget to put a link to this one in the description. Let me know. There will be a link to the tutorial in the description as well, and then this link would be in that tutorial. Now, this is just a quick kind of dump of various cascades. And the way that these work, these are HAR cascades, and the way that they work is they are massive XML files with a lot of feature sets, and these feature sets correspond to a very specific type of object. In our case, we might be looking for a full body. This is a left eye. So if you had like some sort of biometric scanner, you could scan for you could find the left eye and then begin the scan. Anyway, you got bodies, you got faces, you've got lower bodies, you've got a profile face, like a profile picture probably, or something, a right eye around here. Yeah, it's for all kinds of things like faces, smiles, cars, license plates. Time. Till then, we'll grab the eye, and let's get the frontal face default. So these two files, go ahead and take these files, download them. Just take note, these are licensed to Intel, so make sure you understand the license before you go using these, commercially and stuff. So take these two cascades, download them, put them in your, and to download them, you just go to raw, right click, save as, okay? Save them to where you're working, both of these. and then you're ready to go. And here I'm going to show you how they work. So to start, you're going to want to have numpy as np and cv2 imported. And now we're going to define the two cascades. We're going to have a face cascade equals, and this will just be the loading of that cascade. So it'll be cv2.cascade classifier, and then we load in that cascade, which was har cascade underscore frontal underscore, or actually it's not an underscore, frontal face underscore default dot XML, HTML. Anyway, face cascade was that, and then now we're going to say the I underscore cascade, and that file was, let's see, har cascade I.xml. So those are the two cascades that you want. Let me make sure that har cascade was actually called, yeah, just har cascade underscore I. All right, so those are your two cascades. They're loaded in. Now let's go ahead and load in our webcam. So cap equals cv2.video capture. And as usual from the rest of this series, you'll probably use a 0 to bring in your camera feed. I'm going to use a 1 because my first camera is being used. So there's your capture. And then now what we're going to do is we're going to say wow, true. What do we want to do? Or we're going to say ret image equals cap.read. We're going to convert it to gray immediately. So we're going to say gray equals cv2.convert color. Image cv2.color underscore bgr to gray. Now we're going to say the faces here are going to be equal to face underscore cascade dot detect multi scale, and then we're going to detect on gray, and then we're going to say we're going to use 1.3 and 5. We can talk about these probably later. Just you can use these. Basically, it's going to be depending on the size of the image you use and the likelihood that you might find it in your image, you would change these up. But we're going to just use these figures for now, and we'll in the next tutorial we'll probably get far more in depth into that. Then so faces will be found, and then we're going to say for XY width height in faces, we want to just draw a rectangle. So we're going to say cv2.rectangle. We'll draw it on the image. The starting point will be xy. The ending point of the rectangle will be x plus w, and then y plus h. So to draw a rectangle, again, you've got the starting point, then you've got the ending point, okay? And so this is just how we're calculating those points. We're going to make this a blue rectangle, so 255.00, and the line width will be 2. And then we'd probably get away with just drawing just that. But what's going to happen is in faces, you probably want to do, like, you don't want to find eyes outside of a face, right? That's bad news, you know. But even thinking about it, an eye will never be out of a face unless it's an eyeball. And in that case, the features that determine an eye are not going to recognize an eyeball, most likely, because what determines an eye, like your eyebrows will come into effect, your eyelids and your lashes and all that kind of stuff. So morbidity aside, you're not going to find eyes outside of the face. But we will find eyes, hopefully, within the region of the image that the face is in. So we're going to define ROI gray is going to be equal to gray, and then basically the location of the face. So we're going to say y colon y plus h, and then x colon x plus w. So this is just that region. It's that starting point, and then the ending point, and then the starting point again, and that ending point. And with region of image, it's, you know, y then an x, not xy. So we've got that, and then ROI color for later on when we reimpose it. Basically, it is pretty much the exact thing, only image, not gray. Image. Okay, then eyes will be equal to, probably don't need that extra space, eyes will be equal to the eye underscore cascade dot detect multi-scale, and we're going to detect against the ROI gray for our eyes, and then we'll just use defaults for now. So we could, in theory, we might even get away with defaults in the faces, but we might find too many faces. I don't know, we'll see. And then for EX, EY, EWEH, so IX, IY, I width and height, in eyes, we're going to now just simply at this point, we just have to draw it. So we will do cv2.rectangle. We're going to draw it on the ROI color. And then it starts at EXEY and stretches out to EX plus EW and then EY plus A. EH, don't do A. Anyway, and then the color we'll do is 0, 255, 0. And then the line width will be a 2. And then outside of this silly for loop, let's do cv2.imshow image and image. And then we're going to say k equals cv2.weight key 30 and 0xf. Oops, ff. If k equals 27, break. This is just so we can press the escape key. Cap.rel
ノック 勝負して腹ペコ切るだけシュートに入らげでもどこもみんな味わって一つずついただきますって30万円空日のアフターバー僕自前シャリ出た一生でお魚加えて曲がり角食べ最初から全部丸め込むなよノックした君が素敵的で僕の敵に描かされドレスが似合うくびれに釘付けさお嬢様どこにでもなんなりとイケてるやつイケてないやつとか構うなダンスはバリアフリーショータイムを今から始めよういくらか悩む前にできるだけ飛んじゃって教科書には載せれない手段で誰かにこびていないで夢を見て腹ペコもっともっとのショックに入らげ足から足まで手を伸ばせ他の誰かには譲らない30万円割れるまで飲んじゃって僕自前おぼつかない足取りで夜の街に消えていくボーイ教科書には載ってない僕らもなお飛び出すよ広いなバラへシェイキン一生で眠らない夜にスパイス垂らして腹ペコもっともっとドンショックに入らげ足から始まって手を伸ばせ他の誰も欲しがらない30万円埋めるだけ飲んじゃって僕自前荒れた体の血取り足僕は消えていくボーイ익숙해져버렸어 이런 일상마저 표현없다고 생각해 러블리 코스터처럼 흔들리게 되면 스스로 지켜야 하는 건 뭘까 평등한 원리주의 속에서는 뭐든지 이런 내 맘도 가볍게 느껴지는 걸 싫은지 좋은지 저대로 말하지 않으면 인형이랑 뭐가 다른 거야 밤의 거리를 걷는 저 사람들은 슬픔에 빠져있는 걸까 기뻐하고 있는 걸까 컨트라스트가 호선지를 날아다니고 음악과 리듬을 맞춰가 마마의 대화시가 손비롯해 The Beatles 달콤하지만 씁쓸해 정신을 차릴 수 없어 어디서든 좋으니 파티를 계속하자 분명히 세상을 놀라게 향하는 밤이 될 테니까 I feel every night we used to live like that
달려서 우리들의 노래가 당연하게 들린다면 여기를 봐주길 돌아가지 말아주길 아무리 정답이라만 할 순 없지만 여름 축제에 음악은 끝나가고 아직 신나있는 사람도 울어버리는 사람들도 같은 마음이겠지 그래도 진심을 말하려 한다면 서툴기 말할 뿐이잖아 즐거운 휴가 속 행복하라는 다스템 살아가야 할 이유들은 이곳으로 비춰서 같은 속도로 달리면 내일이 와버리지만 생각하는 대로 오늘과 또 업데이트를 했다면 빛이 좀 느리게 흘러가는 someday 정답의 의미가 사라진 대로 feeling song and step 이곳에 내 마음을 노래하는 게 우리들을 우리라게 만들어주신 거가 되니까 QED 나만이 두한 휴가 속 비난 텐데 다스템 살아가야 할 이유들은 이곳으로 모아서 반대쪽 더 좋으니 어느 쪽도 괜찮으니 우리는 언제나 세상을 놀라게 할 테니까 나만의 두한 휴가 속 비난 텐데 다스템 달콤하고 씁쓸해서 정신을 차릴 수 없어 어디서든 좋으니 파티를 계속하자 분명히 세상을 놀라게 할 그런 밤이 될 테니까 I feel every night with you a reflection goes on 즐거움을 넘어서 다시 즐거워져 우리는 다시 즐거워져 La 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 we got the happiness praise and about this
淡々言葉を吐いたあんな思い出に泣いたのは今日で終わりにしないかワンツーの合図を待って You and me 手を取り合ったのは僕の勇気あるコールドフェイス立ち止まんないでいいんだからね空々しいなこの人生できないだなんて言わないでね言わないでね今さらなんて言わないでね僕ら今ささわになって回り始めるだんだん嫌になってでも好きになるねんねわかんないや自分会議もどんどん急に寄ってでも離れてくパッパッとに乗って踊り始める散々嫌になってでも好きになるねんねわかんないやこの先もずっと僕の心をシェイクシェイクイェイ大正解なんてないのさじゃあ一体どこに向かえば物語は終わりますかワンツーの合図を待って You and me 手が触れ合ったのは僕の勇気あるコールドフェイスかしこまったって意味ないんだって恥ずかしがって目にバイバイですこの先ずっとよろしくねよろしくね君と今さっさ交わって目をそらし合うだんだん嫌になってでも好きになるねんねわかんないや自分会議もどんどん様になって崩れ落ちてくパンパンフレーム前に そう笑った寂しいとか愛とかわかんない人間の形を投げ出したんだ抱えきれない言葉だらけの存在証明をこの小さな箱から出会んない気づいたら最後に逃げ出した僕ら全員演じていたんだエンドロールに向かって行くんださみんな必死に役を演じて傍観者なんていないのさ私なんてないのどこにだっていないよずっと僕は何者にもなれないで僕ら今さっさくらいやって延長線サレンダーして目で弱い愛想垂れ流しことの愛想ドラマチックな展開をどっか期待してんだろう君も Yes Yes 気を飲んで采配をスコリアンだへっしょ騒ぐもいもその心を散るいたさまだ見ぬ糸を引いて黒幕の魂さその目に映るのは触れたら壊れてしまった間違ってく様子を黙った僕ら全員無垢でありましたいつの間にやら怪物になったんだその全てを肯定しないと前に進めないかい君にはきっと無理なんだだから君にはきっと無理なんだいつの間にやらガヤにいたんだそんなガヤばっかり飛ばしてきたんだみんな必死に自分を守って救いの手を待ってるのさ考えたくはないよバカになっていたいもんずっと僕は何者にもなれないでだから今前線上に立ってその旗は高く待って劣勢頼る相棒言葉すら必要ないよドラマチックな展開はどっとヒットしてきたろう君も Yes Yes 気を飲んで再会を誓い合ってワンチャンしかない僕の一瞬かけるのさクライマックスみたいな手に汗を握るのさぽつりと泣いた隠してきた本当はどこにもない笑ってきた奴らに場所はない思い出してポイテステ感情はない流した涙理由なんてない優しさに温度も感じられない差し伸べた手に疑いしかない穴が開いてあやたれてしまいなったんだ倒れそうな僕を覗き込んだんだ諦めかけた人の前にあったらいつもは笑うようにお出ました君にはどんな風に見えてるんだ呼吸を整えてささあずっと僕は何者にもなれないで僕ら今さっさくらいやって延長線サレンダーして目で弱い愛想垂れ流しことの愛想ドラマチックな展開をどっか期待してんだろう君も Yes Yes 気を飲んで采配をストリアンだへっしょ騒ぐもいもその心を散るいたさまだ見ぬ糸を引いて黒幕の魂さその目に映るのは
feat.Python, and today I'm super excited. Not only is it the first day of the World Cup, but I wanted to demo the face recognition. Well, you can use this trick in your own example applications. Keep reading the blog posts to learn more. See you later. I'm going to go back to enjoying the World Cup.
実は先輩が好きだって内緒頭ん中ホワイトな感情僕に初めて見せるような表情でもそれは僕に向けじゃないよ本当は止めたいのに約束お人よしなのもたくさんだ残念ですが君はここでゲームオーバーですこんなんで終わるもんか向かうのさわからないないないや心が接してこの想いを今届いてくれよって何やったってダメなんだって味方して君がいないいないいないと不安になって何も手につかなくなってしまうからにもないこと言うなよ泡になって弾けるの
The accent included in this repository in stand which means for so you must get that's fine program ever you stand bunch of
わからないないないや心が接してこの想いを今届いてくれよって何やったってダメなんだって味方して君がいないいないいないと不安になって何も手につかなくなって
It's Raj. In this episode, we're going to build an image classifier using TensorFlow in 30 lines of Python. And I don't mean a classifier that can detect handwritten digits or iris flowers. I'm talking literally anything you want. You'll be able to train this thing to classify chocolate if you wanted. The possibilities are endless. There's so many industries that can be disrupted by just this simple solution. A Japanese cucumber farmer built a machine to detect whether each of his cucumbers was one of 9 different types using this thing. Let's say we want to build a Siraj classifier. If we think about this problem in the traditional programming paradigm, we want to handcraft a bunch of features. Maybe we could do some edge detection to save the shape of my hair, or use a color histogram to save the color of my teeth. The problem with that is there's so much variance in Sirajas. My hair is alive. Seriously, it's never the same. This is where convolutional neural networks come into play. They're essentially a black box that constructs features that we would otherwise have to handcraft. And these abstract features they create from training are so generalized that they account for variance. If we wanted to train a CNN ourselves, we need a lot of computing power and a lot of time, both of which we don't have. I don't even have time to do my dishes. Sorry, roommates. That's why we'll want to use a pre-trained CNN model called Inception. Inception was trained by Google on 100K images with 1,000 categories. Our use case in this video will be classifying Darth Vader pictures. But Inception wasn't trained on Vader, so we're going to perform a process called transfer learning. That means applying the learnings from a previous training session to a new training session. If we look at the Inception model, we get data, increasingly more that last you don't have to install an image that has an installation process, and then you can launch your Docker container anytime easily by double-clicking. Installing the TensorFlow Docker image by pasting in this line. It'll take a few minutes, then once it's installed, we'll move on to step 3, downloading our image dataset to our local machine. We'll stop Docker with Control-D, then create a directory called tffiles/Star Wars in our home directory locally. We'll want to put a folder labeled Darth Vader that contains a couple hundred Vader pics in here. There's this dope Chrome extension I found called feat.Python batch download image that bulk downloads all the images from your Google image search results. Just go to Google image search, type in Darth Vader, and start downloading all of those images. Once we've got them, we'll just drag that folder into our tffiles/Star Wars folder. That brings us to step 4. Now that we have our images in our tffiles directory, we'll want to link them to our Docker container with this command. Boom, all linked up. Step 5 is to download the training script via Git. Just cd into the TensorFlow directory, then run git pull. This code will allow us to retrain the Inception, the actual retrain related. We'll run this image direct, put a training accuracy somewhere between 85 and 99% when it's done. And this brings us to our final step. We want to write a script that will use our new retrained classifier to detect if a novel image. First, we'll import TensorFlow with image path. Our model from it's time on our tensor data. Softmax function is our prediction to terminal image, and I've got a challenge for you guys on this episode. The challenge is to create a classifier that you think would be a useful tool for scientists to have. It can be any field of science you'd like. Upload your code to GitHub, and in the read, create a classifier that you think would be a useful tool for scientists. Think would be a field of science you'd like. how a scientist would use this. Post a repository in the comment section and I'll judge them based on utility and accuracy. The winner gets a shout out from me 2 videos from now, so in 2 weeks, and I'll also send you a free signed copy of my book, Decentralized Applications. For now,